You felt it. You blink, realize an hour has vanished, and you're left with a foggy anxiety humming behind your eyes. Culture calls this brain rot, usually framing it as a simple failure of willpower or a lack of self-discipline. Modern neuroscience identifies this state as a physical override of your nervous system's operating logic. To understand why it feels physically impossible to pull your thumb away from the glass, we have to look under the hood at the mechanics of human attention. The problem of endless scrolling reveals the brain as a highly efficient processing engine that has been deliberately hacked. The entire architecture of the infinite scroll relies on a variable reward schedule. This is a system where a user receives an outcome, like a prize, at random, unpredictable intervals. The brain's reward center operates like a slot machine. Every time you land on a new, shocking post, it dispenses a tiny chemical hit of dopamine. Research shows this rapid-fire hit trains the circuitry to crave continuous distraction. This forces the nervous system to process a comedy sketch, a tragedy, and a dance video, switching emotional contexts every 15 seconds. This 15-second emotional whiplash starves the brain of its ability to enter a singular, focused state of deep thought. That aggressive context switching creates an unsustainable processing demand called cognitive overload. It occurs when the volume of information trying to enter the brain exceeds its working memory capacity. The pressure lands on the prefrontal cortex, the region responsible for complex planning, deep thinking, and sustained focus. This map highlights the prefrontal cortex handling the strain. To conserve energy during this overload, the brain's deep thinking center deliberately shuts down. This localized energy-saving shutdown is what causes the zombie scrolling state, leaving the user physically conscious but completely cognitively dimmed. In early 2026, studies recorded the brain activity of heavy users even after they finished their scrolling sessions. This compares a smooth, focused brainwave to persistent beta and gamma waves, fast, jagged oscillations linked to high stress. These frequencies form a physical barrier. The smooth neural signal required for deep focus deflects off this vibrating wall, locking you out. The intense friction felt when opening a spreadsheet or a printed book is a mechanical frequency lock that must be broken. The focus system remains functional, though currently trapped in a faulty operating loop. Recovery is possible through neuroplasticity. Neuroplasticity is the brain's inherent biological capacity to rebuild, rewire, and reset its own hardware pathways. Resetting the system requires 20 minutes of continuous analog activity. Taking a walk or reading a physical printed book provides the brain with a steady, predictable data stream. This intervention dissolves the high-frequency barrier and restores power to the prefrontal cortex. With an understanding of how your attention functions, you can now evaluate your current engagement. Are you watching this? Or